So we'll start off with how flexibility, security go actually hand in hand in the next generation of satellite constellations. So please welcome the moderator of our first panel, Remco Timmermans. He's the Chief Marketing Officer at EmTroniX, together with Thibaut, Gurné, Allik from Spaceit, and Kaupo, Voormansik from KappaZeta. And they will discuss how flexibility, autonomy, and cybersecurity come together in the next generation of space constellation.
All right, well, thank you very much for that introduction, Johannes, and thank you for my panelists to be here. Let's make sure that they are in this sequence, so you have the right name with the right person, but I think we are. So welcome, everyone, and welcome to the second and last day of the conference, as Johannes welcomed us, and thank you for being here, because this is the morning of the last day, never easy. If you want, you can sit down. That's fine. I'll do the introduction like this, but we don't all have to be standing up here. So as Johannes said, I'm the Chief Marketing Officer of a company called EmTroniX, and I'll leave it to Thibaut to introduce a little bit more about what the company does. But we're based in a country called Luxembourg. Now we are in Europe, so I'm assuming that everybody knows where Luxembourg is. But the interesting thing about Luxembourg, in comparison to Estonia, is it's a small country. It's actually half of the population of Estonia. Yet what we see in Luxembourg is 115 space companies. 4% of the GDP of Luxembourg is space. And that makes it an interesting example, I think, for what's happening here in Estonia, especially since, and we talked about that yesterday, the Luxembourg government in 2017 introduced its space policy and its space legislation, and it put its money where its mouth is. So I'm looking at the policymakers here. That is critical. But when you do that, and you involve the industry, you create this space ecosystem for a small country, 600,000 people in Luxembourg, 115 space companies. Imagine that. So we're one of them, and we're going to talk about the topic, really the topic of this conference, software-defined space. That is what EmTroniX does, and that is what we're going to talk about in this panel, because software-defined systems is part of the future of space. Satellites are becoming more flexible, more versatile, more programmable, more reprogrammable. A few years ago at this conference we talked about OPSAT, and I don't know if there's any follow-up to the OPSAT program in ESA, but that was to test out for the first time reprogramming satellites, repurposing satellites even. And that is what is still happening, still ongoing on a commercial level, and that is what EmTroniX is doing, because we built the software-defined electronics. And again, I'll leave it to Thibaut to talk about that more. But making satellites reprogrammable, in the word reprogrammable and repurposable, there are risks. Because if we can reprogram a satellite, perhaps others can, and we've talked about that in the last days. So from a cybersecurity point of view, reprogrammable systems, flexible systems, bring extra risks. And that's why we have on our panel specialist Mari on cybersecurity. We have an end user of satellites, but also Kaupo, you're building your own satellite constellation at the moment. So I'm looking forward to that. And Thibaut, you're, well, as I said, the specialist on satellite-defined systems. So let's start, if it's okay, with you, Thibaut, to talk a little bit about what EmTroniX does and what satellite-defined systems, software-defined systems really means. So tell us a little bit.
Sure. First, good, the mic is working. Now, it's a pleasure to be here with you at this software-defined space conference. Now, I have to admit something. I'm a hardware guy in a software conference. But up to now, I've been received quite well in this beautiful Estonia. And so I'm indeed part of EmTroniX. EmTroniX is, like Remco said, a Luxembourg-based space electronic provider. And we design and we manufacture our electronics in-house. And indeed, one of the key flagship products that we are trying to put on the market is a software-defined radio or even a software-defined platform. I will talk about that more maybe after this panel or in the rest of this panel. Now, EmTroniX, sure, it's a hardware company. We are designing the hardware, the physical device. But I would even say that we also are a plural-disciplinary company. We have, of course, electronic, the RF part, the mechanical part, but also important on the software part and the system. That's for sure. Now, we are trying to follow these different trends. Like one of the trends is building our own COTS, commercial off-the-shelf component. That's important to drive innovation speed and reduce the cost. Again, we'll talk more about that, hopefully in this panel. But how I like to frame it is build, launch, maybe think about it, and then you configure it and reconfigure and re-innovate on the same hardware. So that's something that we try to endorse as EmTroniX. And then the final word about myself. So Thibaut, I'm a product owner or product manager, depending the terminology you're using at EmTroniX, and that's basically a function at the crossroad between the marketing and the commercial sides and the engineering side on the other side. So basically, it's trying to bridge the market needs together with the engineering capabilities at EmTroniX. So that's it in a nutshell about me.
Well, thank you very much, Thibaut. Perhaps, Mari, of course, I should have started with our female guest. Sorry for being so impolite. But if you could introduce yourself and let us a little bit know about what Spaceit is doing.
So I'm Mari Allik, Chief Operating Officer at Spaceit. My background is also hardware, testing of space technology, different subsystems for almost 10 years. So now I'm into software. And Spaceit, as a company, develops mission control systems. So we enable the satellite developers to buy ground station contacts, scheduled contacts, so they can use our software to operate their satellites. And we try to do it as secure as possible. And when you mentioned OPSAT, then we are actually in this ESA project, OPSAT Oriol mission. So in 1 year, we will launch a 16-unit CubeSat. And it's the second OPSAT satellite developed by C3S in Hungary, and the payloads will consist of optical communication module developed by Goldberg Space and thermal imaging, and also the optical communication is very interesting to test even inter-satellite links in the future. And we will provide the mission control software and operate the satellite and get exciting photos and images. And we also have the Space Cyber Range. It's a European space agency project we are leading together with partners from CGI, Cybexer Technologies, CR14, and the University of Tartu. And you will hear more about it very soon, I think.
I hope so, because that's what I asked you in the preparation. So thank you. Kaupo, can you introduce us to yourself and to KappaZeta?
Thank you. Yeah, I must admit that I'm also a hardware person. After graduating high school, and I was especially fascinated about computer hardware, and I studied the hardware side of computer science in university. So we have a hardware panel here. But this was a long time ago. I've forgotten everything. My background is synthetic aperture radar. I did a PhD in cooperation with DLR, Germany, and also small satellites. I was the systems engineer of first Estonian satellite, SDSC2025. And actually, when we talk about software-defined systems, then SDSC2025 was already a very good example of a software-defined system, because basically pretty much what was launched was kind of like empty hardware. And then by the need, like the software was constantly updated there, and eventually way more capable system was up there than right after the launch. In the audience, Erik for sure knows way more about it, but I think he can confirm that was the case. KappaZeta, we are Earth observation services company, extracting information out of satellite data, applications in agriculture, forestry, and defense. We are the service provider for Estonian and Danish government in Denmark via a subcontract with a local company, DHI. We are also serving now a third European country for the same agricultural subsidy checks, which I cannot name yet. The idea is very simple, like historical inspectors were checking the fields, but now you can do a lot of this validation with satellite data. And yes, last but not least, we are building a new constellation, a mini constellation, which is clever. It's like less sats, but more data. Very low space debris footprint with just 3 satellites. But the amounts of data is actually comparable eventually to what Planet is acquiring with 170 satellites. And yeah, we completed phase 0, started phase A, and looking to build and launch the system in 2029.
Excellent. So software-defined is one way to make satellites more versatile, and exactly as you say, not contribute to space debris so much. But what you're doing is that as well. So I really like you mentioning that. That's important. But before we continue there, Thibaut, in your experience as a product owner in space electronics, what trends do you see in satellites becoming more flexible, more agile, perhaps repurposable, as we said before, by the use of software-defined systems?
Yeah. So let me elaborate on 2 trends that we see at EmTroniX in this new space 2.0. You know, I'm talking about this new space paradigm, and I think it has been around quite a while. It has been also shifted in a bit. I will not elaborate on that, but I think that's shifted enough to my humble opinion that we can call new space 2.0. And one big trend that we have seen is, well, space infrastructure are hardware. So yeah, but more and more software. That's undeniable. The space industry is really shifting towards software-defined systems, enabling greater flexibility and adaptability, as I already said. And an example of that, of course, is those software-defined satellites, such as those using reconfigurable processor and reconfigurable FPGAs and so forth. And of course, it was also mentioned, it allows in-orbit reconfiguration and so forth. Like I mentioned, you build, launch, you think, you configure, reconfigure, re-innovate. You can continue to innovate on the same hardware. So that's quite powerful. Now, the implication on that is you have faster development cycles. You just launch it and so forth. You have increased reliance on software expertise. So that's why this kind of conference is very useful. And then that brings also new opportunities for innovation and entrepreneurship. So that's also good. And at EmTroniX, I would say that we fully endorse these trends by providing a software-defined, I would even call it a platform, with a big, powerful SoC, a system on chip, with an FPGA, with processing units, with different configuration memories, with other type of data memory. And the first product of this platform is an SDR, a software-defined radio, with multiple synchronous RF channels that the user can use. But this platform is, can also be a base for more products. You just put an, that's already a RF front-end, but you do put a power amplifier in the X-band, and you have X-band downlink. You still have the digital core to control it, and you have an X-band downlink. So that's another product. You had the receiver and the transceiver. You have a receiver and transmitter. You have an X-band transmitter. X-bands, you just press with a frequency, and you have a K-band transceiver. So that's a way to answer your point about that's a difficult word, repurposability of the design of this platform. So that's definitely something that we're doing. So hence, the point I was trying to make, hardware infrastructure, yes, but more and more software. So that's one trend that we see. The other one is, well, innovation goes very fast, and therefore available products are used, and so the development of these products needs to be anticipated by a manufacturer like ourselves. And so for that, the space industry is leveraging COTS, commercial off-the-shelf components, which help to drive innovation. An example of that is the spread of, an example of this speed of innovation is the use of AI and machine learning in satellite operation. That's not even a debate. We all assume that AI is part of our design, and so it's straightforward. And the implication, though, is that hardware needs to be ready for this stream of innovation. COTS manufacturer, like EmTroniX, we need to anticipate the future needs to be on time. And that circles back to my first point, my first trend about software-defined radio. It allows this kind of innovation. And so definitely EmTroniX is trying to follow this kind of trends by proposing COTS, commercial off-the-shelf components, with even a roadmap to assist AI application in our product. So definitely two trends that we are trying to follow in the sector.
Okay, real briefly, because this is important, that as a hardware manufacturer, you need to be ahead of these trends. If we, as an industry, want to apply AI at large scale next year or in 2 years in satellites, the hardware needs to be ready for that. What's the development cycle typically for a new hardware component for a satellite?
I would say it depends on platform, but EmTroniX, we are trying to be smart. That's the idea, right? To make sure that the platform that we are using is very flexible. That's why we call it also Spaceit in Luxembourg. It's also easy word to pronounce, but it's very flexible, versatile. So indeed, we are using a kind of stock currently, which is not so much for AI. But in the future, in a couple of months, depending on the needs, a couple of years, we could have a more AI-based system on chip that really could help with this AI application.
Okay, thank you. So yeah, we need to be ahead of the curve by a few years, and that's not always easy. Mari, with satellites becoming more and more software-defined, so software-dependable in a way, how are the cybersecurity risks changing, and how can we make these software-dependent systems more resilient against cyber threats?
So it's a very good question, and many years ago, satellites were launched with only the hardware side covered. So yeah, the software was kind of hard-coded. You couldn't update things. Now you send up satellites that have the software doing almost everything. So you can actually change the functionality of the satellite when it's launched. And that makes it open to threats, of course. So if a computer has a virus or malfunctioning, you can just throw it away, buy a new one. If the satellite gets hacked, yeah, then it can send different, different software to other satellites, and just the whole constellation can stop working or stop working for you. So currently the risks are that the software, it can be not hacked. There can be attacks on satellite software on ground segment. Not only the satellites are under the attack, but also the ground segment, because communication with satellites need to be secure. If someone else can send commands to my satellite and these can be somehow decoded by the satellite, then it's very bad for me. So I think there are a lot of risks that we don't think about when designing the satellite. We should do it already in the design phase, not when the satellite has been launched. Oh, we have this software on the satellite. It doesn't do what we want to. Oh, it's hacked by someone else. So in order to get the functional satellites into orbit, I think when they are built, they should be tested for cyber threats. So we have the Space Cyber Range developed with European Space Agency and other partners, and it enables to test these scenarios on, for example, FlatSats, connecting different ground station segments into the cyber range, and you can actually simulate all these attacks. So you can try the worst case scenario, and you can see what the solutions are. So if you do this by day one, then I think you are quite safe, hopefully, in the future.
It's interesting that you say so, because it was here where I learned about space cyber ranges for the first time. And the people on stage, they acted like everybody in the audience knew what a space cyber range was. I had no clue. Can you give us the two-sentence summary of really what a space cyber range is and why all satellite software and hardware manufacturers should link up their systems to a space cyber range before launching?
So it's a virtualized environment where you can connect your flat set to the environment. You can upload software to it, and you can communicate with the satellite. You can send different attacks on the satellite, and then you can try to protect the satellite. So it's a virtual environment, but we have physical equipment as well in CR14. Currently, they have been, I would say, installed, I think, last week. So it's very exciting, and it will be open for all European Space Agency countries to connect to this space cyber range to test their worst-case scenarios.
Both on hardware and software, because that's important. We can bring our equipment, link it up, and run these scenarios.
For example, SDRs, you mentioned software-defined radios, and you get so much out of this. You can do different exercises, so red team, blue team exercises. One team is making up different scenarios, how to kill the satellite in maybe not so nice words, and the other team is protecting the satellite from all these threats.
And you provide those teams. You have your hackers.
We have everything, yes.
Ethical
but you can also
hackers.
join if you feel like.
No, but that might be an interesting exercise. And I mean, not just for us here, but of course, we're talking about the industry in general. Because what that will do, hopefully, is and I'm asking you, is some sort of a seal of approval or some seal that we reach a certain quality level. Are there norms, for example, in ESA for cybersecurity resilience?
There are norms that we need to follow, but these are, I would say, being in development currently, because it's a quite new thing. We all think about cybersecurity, but we need to do more tests and see what the outcome is, and then we can integrate this into the space laws and so on also in the future.
Interesting. So there's a space policy element to it as well. So I'm sure we had the lawyers on stage yesterday who talked about that, but I was just wondering, because what we want as an industry, I suppose, is towards our customers, and Kaupo, you're one of those customers, if you like, is we as hardware, software providers want to make sure that the systems that we provide to you, because you're ultimately interested in the data and not so much in how we built the satellite, as long as we get you the data, but that you are certain from the beginning, from the get-go, that a system is cyber secure and that it works now, but it will also work in the new geopolitical reality of today, but also of 5 or 10 years. So Kaupo.
That's interesting. That boils back to a question that was asked yesterday about the responsibility of the cybersecurity being the CUTS manufacturer, for example, EmTroniX, or the end user. So I received some answer about that, but it's still a bit unclear. I would say sometimes it's maybe a mixed responsibility. The way, everybody needs to make his part at certain cost and security, depending on the application. So.
Well, I guess because it's all about a data chain that involves multiple parties. And now, Kaupo, you're at the end of that data chain, if you like. So for you as a space data company, let's focus on the software-defined bit before we go back to the cybersecurity bit. What are the biggest benefits, opportunities, threats maybe, of software-defined satellites, and how do you ensure that your customers of your data receive accurate, factual, timely, and relevant data?
The benefits are flexibility, probably also, potentially also lower cost. You don't need to relaunch always. The threat obviously is hacking, that update speed is nothing without update trust. At the moment, yet it hasn't become an issue with the Sentinel data we use. But as you mentioned, this new geopolitical reality, we cannot assume that nobody will hack. We must be ready that somebody will try, and also about our mini constellation of 3 satellites. From the beginning, it must be designed so that it survives the hacks, and you can you can live it. And I think one of the keywords also there is the modular design, that make everything modular. And that's like hacking one node doesn't mean the hacking whole network. And that's a good design principle.
As a customer, as a data customer, how do you, or what do you require from your data providers in terms of cybersecurity or accuracy of data, if you like, reliability of data?
I think integrity is the main thing, that what we receive is the actual measurement, because based on this, for the governments do, let's say, payment decisions, and if it's wrong payment, then it's a problem. They must trust the data. It's not so much the privacy of this. If we take the agricultural field, see, somebody copies it, somebody knows it, let them know it. But we want that it's really the real measurement and it's not some manipulated one.
Yeah, we saw the examples yesterday. Joe showed us very clearly some examples of mostly real pictures, but also a few fake pictures.
Yeah.
And that's okay. Thibaut, let's go back to you. What measures does EmTroniX take to make electronics and RF components cyber secure by design? Because that's what we talked about a lot in the last days, and you mentioned it as well, Mari, is security, cybersecurity by design. What exactly does that mean to a subcomponent manufacturer like EmTroniX, Thibaut?
So, yeah, that's an interesting question and hard question. And in all transparency, honestly, if it was crystal clear for me, I would not come to this conference except for the good food. But it's a good question. It's a good question. I have my views, and please be critical with me and see what we can do. Now, you asked a question on two parts. So yeah, first the hardware part. I would say that a good electronic design needs to be a robust design for space environments. So, for example, for this design, you need to be EMI proof, so electromagnetic interference, and so basically you need to have RF shielding of your component, you need to have isolation and so forth, and that's a way to avoid all your signals leaking everywhere, all the parasitic effects leaking everywhere on other subsystem, and that would alter those subsystems. So that's important that we do this kind of protection, but that's also a way to prevent unauthorized access to the platform. If you want, that would try to gain some information about the platform, how it functions. So that's one example that we do. The other one, for example, if you look at the power-up sequence, a good power sequence, secure power management system has like a sequenced power-up sequence, and that's a good way to prevent your design for power burst. But it's a good way to counter some power-related attacks and so forth. So, and then while saying this, I'm thinking, okay, wait, this is about the satellites. It's not easy to go with your probe and your scope up to the satellites, right? But on the other hand, I think it was yesterday, the talk of Florence from ESA saying that a spy satellite is a thing, right? So yes, that's something we have to keep in mind to keep our RF design or electronics shielded to the best of our ability. So that's about hardware. Now the other part was about software. Software, interesting part. Of course, in our product, in our platform, we do have the possibility for encryption of the different data communication channels. That's for sure. There are different IPs that we can instantiate in the big SoC, the big system on chip. So that's definitely the case. And then the other point is the reconfigurability of the software, of the software-defined radio. That's indeed the biggest advantage of an SDR, is that you can reconfigure it on the air. But that's also a big security breach, potential security breach. Now at EmTroniX, we have this kind of triple redundant configuration memories that you can have your memory in triple redundancy, your configuration in triple redundancy, and if there is an impairment, if the system see that there is an impairment on this configuration, which can be because of a space event, by the way, or because of a cyber attack, the system has a last golden memory with a basic setup which allows the system to go to a state where it can reconfigure itself through secure channels. Now, I'm happy that Frank from Thales is there, because I had a long discussion with him yesterday about what this secure channel is indeed. Because it's nice, but if you reprogram your chip or your design with an unsecure channel, well, you're back to square one. And then my conclusion there was to say, well, you can have a dedicated control block that encrypts this secure reprogramming channel. But at some point, you need to make the trade-off between the cost of all this security that we implement and the necessary needs for the application. So it's a bit of a trade-off in there.
It's interesting that you mention it as a trade-off, and in the conversation before, Kaupo, you also said that cybersecurity is super important, and we talk about it a lot here, but it can't be so important that we make it so secure that the system becomes uneconomic. So if you don't mind, can you tell me a little bit about how that trade-off works, again, for a client of makers like EmTroniX?
Mm-hmm. If I may come back to this cyber ranges topics and testing on the ground a bit, then actually you can do a lot on the ground. You can draw enormously on the ground. And what we do, for example, with this 3D constellation currently, is receiving this Sentinel-1 echoes from the ground with the same hardware, with similar software, and you don't need to launch it to the space. The only difference we get, of course, like this radiation-hardened hardware, and this is a topic we definitely need in space. But all the other components, basically all the processing chains, the hardware functionality, you can test on the ground. And we have already received this Sentinel-1 signal on the ground and all the processing chain. So it's not necessarily costly. I think it's being clever. And this is the way how we do that. I don't know if it's a trade-off, but it's like to save costs. We don't need to launch it to test the functionality.
Right. Well,
I'll just comment on that. It sounds like Kaupo has their own space cyber range already in Kappa, so you can also join ours. Yeah. Very nice.
But tell us a little bit, Mari, about how space cyber ranges, yes, it comes at a cost in the beginning, but how can it help in this trade-off? How can it basically make the entire process more efficient and maybe even cheaper?
So first of all, you can test all the layers, all the communication layers, all the protocols, everything that you think that it will work in space when the satellite has been launched. You can test it. You can change hardware. You can do a lot of things before even launch. So I think the space cyber range benefits in this way, in ways that we can't really even imagine now today, because there are so many different tests that can be performed. And just maybe a comment that as I worked as test engineer, I know that shock testing, vibration, and thermal vacuum is really important for satellites. But I think equally important is all the software tests in a cyber environment, all the attacks on the satellites, because then you find out the weak spots of your system, and these can be fixed then now before the launch. So I think the cyber range, as we have tested some flat sats already connected to the cyber range, you can see that the results are very good in that sense that they prevent things happening in space. Maybe
that's a good comment in sense. Indeed, because when we develop components for space or system, indeed we have this TVAC, shock, vibration, and so forth. But up to now, up to my knowledge, we don't have cyber security check. So indeed, that could be part of the qualification program for design.
Yeah, well, and that's really why I asked about these norms and standards that we may have. But interesting is that, of course, when we talk about software-defined systems, we can fix problems even after a satellite has launched. Now, tell me a little bit, Mari, about the role of these cyber ranges, perhaps also in the life cycle of satellites, and how can they help us to extend the life cycle because they are software-defined. I mean, you could test it for threats that we have now, but in 5 years we may have even smarter hackers. I hope you will employ them. But there may be threats that we can't really foresee now, and maybe things like, and I'm thinking out loud, and because we have the quantum experts sitting here in the room with us, that quantum, yes, will provide an extra layer of security, but it might also bring us new ways of hacking systems, smarter ways of hacking. How can cyber ranges help us, say, we launch a satellite now in a few years? Does it make sense to retest it and then make the satellites more resilient, even while they're already up in space?
I think that's one of the goals of the cyber range, because you launched the satellite. Let's say you launched it yesterday and you didn't have the chance to use the cyber range yet, but you still mostly have a flat set of the satellite available with the software solutions. You can still connect it to the cyber range and you can test scenarios. And if you have some worries about the future threats, if some new attacks arrive, you can actually test them, and then you can update your software on the satellite which has been launched to protect against these future attacks. You mentioned quantum as well, so quantum key distribution is something that might or is already happening, so this is also a way to keep satellites safer. It can also be a big threat. You don't know how to use the quantum key distribution systems, but I still think that there's a lot of exciting things will happen in the future, and the cyber range will not disappear anywhere, so it can be used also for satellites that have been launched. We are almost connecting OPSAT-1 to the cyber range soon, so it's in progress.
OPSAT-1 was launched when?
Sorry, can't tell the date.
It was a few years ago.
Yes, but we needed to test some safety implementations. So this is also one point of this cyber range.
Yeah, and that's a good example of exactly what I meant, is even though the systems are already up there, we can still work on making them more secure.
Also the OPSAT Oriole that will be launched next year, it will also be connected to the, it's not all of the systems, but IPC, some intelligent payload controller will be connected to the space cyber range, able to do exercises, for example, because OPSAT people can register experiments for the OPSAT. What says that your experiment is safe? You want to upload it to the OPSAT. We have to somehow, test it.
And that's interesting, because OPSAT is a good example of having multiple customers of one satellite that will upload their own software into the satellite, which is all different and all has its own cybersecurity risks, I suppose. So, anyway, I'm just thinking out loud. We got a question in here, and it's actually interesting because that question is the question, not that I put it in, but it's very similar to what I was going to ask you, Kaupo. So perhaps I can ask you to answer this question. Let me, is it on screen? No. Can you put the question on screen here? Or doesn't that work? Because then everybody can see. If not, I'll read it out. Oh no, here it is. So yes, as hardware experts, and apparently we're all hardware experts here, how best can the lessons identified from hardware resilience be fed into secure software-defined systems by design? Is a standardized approach, and I guess that's a real question, is a standardized approach needed across the sector? What do you think of that, Kaupo?
I'm not sure I fully get the core of the question, but I think as any hacking or it's not any magic, but it's just understanding the system very well. It's just knowing your system to the bones. And of course, the hardware and software, let's say, behavior is connected. And sometimes with running some specific software, you can, let's say, even destroy the hardware. And I am not a big fan of over-standardization. I think too much rules is limiting. Just trying.
But can we leave it to the industry itself to self-regulate? Because we get a lot of criticism from our American counterparts as a European space industry that we're over-regulating things and that we're making things so difficult that we cannot be competitive. Is that sort of what you mean?
Partly, yes. I think we should define the requirements and the end results, but we shouldn't go too much into how, because going too much into how will become obsolete rather soon. Mm-hmm. Yeah.
Yeah, and I know we've had that discussion in the Estonian space law presentations that we've seen, maybe not so much in this conference, but in previous years when there was a lot of focus on how do you balance space law to be supportive and not a blockade, if you like, for for development. So I guess that's what we're talking about here. Now we have 4.5 minutes left.
But Remco,
Yeah?
I do like the questioning indeed, but that's going back to what Mari said about having this step part of our qualification process, to have this this analysis and the security label that you have on our product. Okay, it's TVAC, okay, it's vibration test and so forth, and it's from a cyber security point of view, it's also okay. It would give added value to a customer. It's like, okay, because I can say, well, I'm from EmTroniX, we did a great design, and we did actually, and it's 100% cyber secure. I mean, you need to trust my word on it. But if you have kind of, I know, I understand your point. Too much regulation is maybe problematic, but having a kind of label that, okay, we did that and we test that with cyber range, I think it has some value.
It does. I'm not telling we shouldn't have any regulation. I think even if, let's say, incomplete or faulty plan is always better than no plan. So,
yeah.
We can give out certificates
There you go.
that your satellite or your systems passed the tests and you are ready to fly or ready to develop the hardware further. And
Spaceit approved.
Yeah, well, no, I mean, we laugh about it, but that's kind of what is needed.
Yeah.
I mean, you need to do your TVAC test, and we showcase that to our customers.
Yeah.
Okay, our systems have been TVAC tested up to these levels. A similar thing could be we have its cyber range tested, and we've tested it up to these levels. And these levels will become more and more stringent over time, and you can help us maybe develop that. But seeing it as a quality label, I think brings added value to our customers ultimately, and that helps us as an industry to raise that quality bar and raise that cybersecurity bar, even to a level that we may set an example to other industries, because we've said that cybersecurity in space is, in a way, we had a debate yesterday actually about whether space cybersecurity is different from cybersecurity on the ground, and most people here arguing that it's really not. But we can set an example because we have extra constraints. Anyway, I digress. We have 2 minutes. I would like to invite each of you to give us a short final statement about, well, where is this all going? And let me see what my question was. Yeah, what are your key recommendations for the industry to get maximum benefit from software-defined satellites while minimizing cybersecurity risks? Thibaut, I'd like to start with you in less than 1 minute because we have...
Are you sure you want to start with me? Because we can start with the lady, because it's up to you.
Mari?
Okay, yeah. So I can make it quite short. So I think the key is to try to list all the risks as much as possible, and try to minimize the risks by testing. So a lot of tests in the space cyber range, for example, but it can be a lot of things that can be done in-house already, and then when you're ready for the cyber range. Think of things that might happen in the future, like try to be a step ahead. So, and always, if we talk about satellites, it would be good to have a flat sat, some kind of model where you can test software solutions before you update the satellites.
I think that's pretty standard anyway in satellite manufacturing.
Yeah,
so
not always, but
well,
yeah.
Good recommendation. Kaupo, what would be your key recommendations to get the benefit while minimizing cybersecurity risks?
I think it's keeping the updatability and updatability with trust. Update speed is nothing without update trust, and update gives you flexibility. Okay,
and then Thibaut, you have 35 seconds.
Yep, so what he said. But beside that, also the trick as well for a COTS manufacturer is also to anticipate the needs or the requirement in our COTS product. So from a hardware point of view and software point of view. And I would also even add that cyber security is a mixed responsibility. So COTS manufacturer and end user, we need to work in tandem to have the cyber security across the entire chain.
I think that's a great way to finish. So with 3 seconds on the clock, I would like to thank you very much. A round of applause for my panelists, please. Thank you very much. And I'll hand it back to Johannes.